approximately 2 to 3 videos on the wiring up of the whole machine and the setup with Mark III. So I've got everything that I need to in here, the hardcore parts. So I'm going to start with the 230 or 220 volt AC mains power supply, and we're going to split that up into 2 separate circuits. Now the one circuit is going to supply the VFD for the spindle. Now the VFD is going to convert that 220 mains voltage AC into 3-phase AC 220 volt. Okay, that's one of its jobs, to run the spindle. And the other circuit, the second circuit, is going to supply this power board, which is a good standard power board, which in itself is isolated, and it has a overload switch on it as well, and it also has a 5 volt output. Well, I'm going to use one of those 5 volt outputs for the fan at that end. I know I'm going on to 5 volt now, but it's at that stage. And I've got a 5 volt converter here, 5 volt DC converter, to supply the 5 volts required to run the stepper motor drivers. And of course off here I'm going to supply these 2 power supplies here with mains voltage 220 volt as well off this board. Okay, so we'll make a start. Just a reminder before we start, if you do anything with electrics yourself, you must consult with a local electrician in your region, because your region may have different regulations to what we have here. And before ever you switch anything on, you must have it fully checked out by a qualified person. So we're going to start with wiring the 3 units which require 220 AC mains power. And what I've done is I've just gone out and bought some extension leads. These are 10 amp leads, just short extension leads, because it's cheaper to buy a ready-made lead like this with a plug on it. Alright, because that's all I'm after. It's cheaper to buy this 2 meter lead ready-made than what it is for me to go and buy a plug and a length of cable. Okay, it's just as good, because that's all I need, that length like that. So I'm going to cut this, spline it back, put some connectors on it, and connect into the VFD and the 2 power sources individually. I find these type of crimping pliers and wire strippers very handy. They're very cheap, so you just put them in the jaws like this and pull. That's all you need, and just twist the wire like so, stop it fraying. Then get one of your connectors, put it in there like so, so the copper wire just comes through. And this, in this case, this is a blue one, so you put it in the blue marked area like that, and crimp it nice and tight and that's how to crimp a wire on. So you do that to all your wires that need to be into little spade connector areas, and we'll connect the wires on. Okay, before we go connecting up, there's one thing you need to do with your power supply for your stepper motors. Is you go to the switch on the side here and choose your voltage, or your region's voltage. In Australia's case it's 230, 220. AC voltage does vary between 220 and 240 actually, so this is sort of set, this figure's set in between. So the switch is in the right position over that way, so we're good now to wire this up. Now these wire up very simply. You just flip the little plastic cover up. Now what I do is unscrew these first, just loosen them up, and on the front of the panel, if I can show you this, like that, you have earth, that's an earth sign, neutral and live. Okay, so it's very important to get the wires in the right place. So I always start with the earth, which is, in Australia's case, is the green wire. So that just slots in like so, and you tighten it up firm. We'll be coming back to this terminal because we have a second earth to put on there, one to be fed to the spindle motor itself. So the next one we're going to put on is the neutral. Bit fiddly, trying to get your fingers through here. There we go. He's on. Nice and firm, and then turn that wire around. Okay, so now it's the main supply to the VFD, and now this wire goes into the big junction box that I have already fitted in the unit. So the next job is to connect up the cabling required to carry the 48 volt DC to the drivers, and I'm just using some of the same cable, but I'm cutting out the earth lead because it's not required. Okay, connecting up the positive negative of the DC, you don't require a spade connector on those. Just peel the insulation back and twine the wires together. Now the first three here are positive and the next three are negative. So I'm going to choose this last one here. Put that in there and firmly screw that down. Then I go into the center one here. It's up to you, whatever you choose. Doesn't really matter, but this works for me. I get my hand out the way. It's in there firm. So that's one pair. And that's all the connections for the 240 48 volt DC converter power supply. So now I've placed all the components in here, and you can see I've started to tidy the wiring up. I've zip tied all this group together. This is all DC power. This is all 48 volt DC power coming out of these power supplies. This is a 5 volt supply, which is here, which is kind of going to come and supply all the drivers with 5 volt DC. This particular wire supplies the fan over on the side there, which pulls air through. That's 5 volts, and that's plugged in just here because there's a 5 volt supply USB port on the end of this power supply. This big junction box here, this is going to house all the connection blocks, such as these, which connect up all the different cables for 240 volt. Now, I have the very modern and expensive fuses, because I've got two separate circuits. One circuit supplying this power board, and the other circuit supplying this, which is going via these two switches. So I can switch, I have a control where I can switch this circuit off if I want to work on the machine, but have the machine run, but not the spindle, for safety reasons. So you have to separately fuse them, separately fuse the power lines. Now, you might think I'm a little mad here, because I got one wire going into a loop. There's a good reason for that, is because I'm going to put these on this carriage here, this holding carriage, and the wires are going to go down through into this box. So I know that that loop, that one is connected to one, and this is connected to the other, because then I can cut that wire through and know I've got, you know, I'll know which side is which. So then I can connect these up, you know, one to the inlet power, which is, let me see, here. This is the inlet power. Okay, and this is the inlet negative. Alright, so I'm going to connect one end of two of these wires to this brown lead, okay, which feeds power to these. Then coming out of this, I'm going to feed one of these to the power supply, which is these leads here. I know it sounds a bit complicated, but the leads here that go to the VFD. So one of these ends is going to be connected to the power side of that, and I've got an earth wire, okay, going directly to the bodywork of this, which is directly coupled to the earth lead coming from the plug from the mains supply. This is the mains supply. Okay. So no, I won't tell you any more because I don't want to confuse you. All right. So I just want to really explain this. Okay, and I will tell you this as well. These two black wires here, okay, they're coming down from these switches. So there's going to be similar sort of affair, right? There's going to be one live lead going up to the switch, okay, and then the other side of this coming down and then feeding the one of the two individual items that needs supply. So the power goes through the fuse first, then up to the switch, not the other way around. Okay, so I'll get on and put these in here. Okay, I just brought you in for a bit of a closer look there. So now you can see there's the one brown wire with the loop in it, and there's the other one. So we know that, you know, one of these wires is connected to one, and in this case the one on the left is the one on the left, the one on the right is the other one. And you can see that how they go. One wire goes up through the back there, loops around and up into the top, and the reverse over there. So now we can put the cover on that and forget about it. And then we can start connecting up the different circuits in here. And you'll notice I've got some shrink wrap on here, which is red, which is indicating positive and positive. Okay. Coming up from the switch, which is up the top up there. Now, without confusing you, the dead man switch does not work on this circuit whatsoever. It works in conjunction, it's a signal wire to work with Mach 3 through this board directly to the computer. So this cable and this switch is directly connected to the computer, not this unit. And it tells Mach 3, the program, shut off. And while I'm talking about this board, and this is a earth for the board itself to the body, okay, which is earthed at the body here as well. Okay, and there's those two earth wires. There's one there, okay, which goes into this yellow cable, which is the power supply from the power plug at the mains on the wall. And this one is going to supply earth to all these different units. Okay, so I've connected this up, and I'll run through this now with you just so you can probably understand a little bit better how it's connected up. So here we have the incoming line, which is 230 volt. Main supply AC. Now I've peeled the insulator back to reveal the earth cable, and I've connected that into the body, but I've also taken an earth from that cable and brought it into this junction box and supplied an earth to this unit here, and the second earth goes directly to the VFD. So that's the earth taken care of. Also, because this now is connected to earth, this also supplies an earth to the Mach 3 circuit board. Okay, so that's the earth taken care of. Now the next thing then is the neutral or negative. Now here's the neutral line coming in from the main power supply in, which splits to neutral to the VFD and also neutral to this power board. Now the live gets not really complicated, but it's a little bit more complicated than the rest. So here's the live coming in, which now splits into two lines, okay, which feed directly into these fuses. If you notice, one is for the stepper motors, in other words, supplying power for the power supplies for the stepper motors, and the second one is for the VFD. So there's the two lines going to the fuses. These two lines here are coming back out from the fuses. These in turn are connected to two separate cables going up inside to these two switches. So these switches are after these fuses. So you can individually switch on and off the two separate circuits, being the VFD and this power board, which supplies power to the stepper motors or the drivers. So here we have power going up to those switches, and these reddish cables here are the power coming down from these switches, which go then, which one is connected to the VFD via this cable to here, and the second one, which is this cable, goes to the power board. So we have isolated circuits, okay, totally separate circuits, one for the VFD and one for this power board, totally fused and earthed. And if you notice what I have through here, now it is a requirement in most Western countries to have double insulation. In other words, you can't just rely on the insulation of the cables. You must have a secondary insulation, especially if it passes through a metal casing. And that's what these are doing. This one, obviously this one here is bringing the power in, and the two larger ones at the top are for the stepper motors and information from the limit switches and other power feeds out onto the machine. There will also be an earth lead taken off here separately to the machine chassis. You cannot rely on having this directly screwed to the metal to give you an earth. You must give it an earth. So that really takes care of the high 240 or 230 AC power into your electronic box. So the next thing I'll do now is actually fit this electrical box to the CNC router permanently, and I will run all the other cables inside here and out onto the machine while this is in place. So I've got the electrical cabinet bolted back in there now. Okay, and now is the time, and I would suggest to you that if you are not electrically minded, before you switch it on, which I'm going to do in a minute, is to have an electrician check out your work before ever you plug it in. And I want to stress that to you. Okay, so here we go. Let's test it. Now, prior to this, I have tested it with a meter to make sure all the circuits are correct. So that is switched on. So now we're going to switch the fuses on, and we'll try one side at a time. So the stepper motor or the power supply side first. Okay, so we've got a blue light come up here. The fan's going now, so I know I've got power there. Now what we're looking for is green indicator lights, LEDs, on the power supplies. There's one, and there's two, one there, look, one back there. So everything is green and okay. So that side of it is fine. So let's turn the VFD on. That's a normal response. Now that is the factory setting for frequency of 50 Hertz. So everything is clean and green. So now I have to check in that, and I advise you again to get an electrician to do this for you. Now it's okay to switch everything off. Unplug it. Never work on it with it plugged in. And you see the LED lights are still lit, they'll dim out and go off. So the 240 side of things and the three-phase side of things is working just fine. So now we can move on to connect the power feed up to the drivers and to connect up the Mach 3 board to the drivers and the VFD three-phase up to the spindle.